This video will give you an overall understanding of mathematics of vectors. As you know, mathematics of scalars has two parts in general. One is scalar algebra and second is calculus of scalar. Algebra means addition, subtraction, multiplication and division. And calculus means derivative and integration. Derivative is nothing but the rate of change, and the integration is an area. Similarly, the mathematics of vectors is divided into two parts: algebra of vectors or vector algebra, or calculus of vector or vector calculus. Like scalar algebra, algebra of vector has addition, subtraction and multiplication. But we don't have the division of vector, so it doesn't make any sense. And the vector calculus has two divisions. One is a derivative of vector and second is integration of vector. The vector algebra, the first part of vector algebra is addition. In addition, what is the use of addition of vector in physics? In mechanics, kinematics, you will study how the displacements can be added, addition of displacement to get the net displacement, addition of velocities to get net velocity, addition of forces to get a net force. Net means resultant. In subtraction, we can write velocity v2 is subtracted from velocity v1. v1 minus v2, this will give you velocity of 1 with respect to 2. So this is the idea behind the relative velocity. Similarly, we have relative acceleration. Acceleration of an object 2 is subtracted from the acceleration of an object 1. That is called relative acceleration. So the subtraction of vectors can be used in this way. This is the relative velocity, this is the relative acceleration. This is the net or resultant displacement, net or resultant velocity, net or resultant force. We can add more vectors also. This is the addition of vectors. So we will use the concept of addition of vector in kinematics and different parts of physics, different areas of physics. We can use the addition of forces, addition of velocities, addition of displacements. And this can be called superposition principle. Superposition principle. Addition of vectors can be called superposition. In different parts of different areas of physics, we can use the concept of addition. And subtraction of vectors can be used. mostly in the chapter of relative motion, relative velocity and relative acceleration. Velocity of 1 with respect to 2 can be given as velocity of 1 minus velocity of 2. Acceleration of 1 with respect to 2 can be given as acceleration of 1 minus acceleration of 2. All these things will be discussed in detail in the respective area, the respective chapters. All these things will be discussed in the respective contexts and different chapters. Now come to the multiplication of vector. In multiplication we have 3 subdivisions, like scalar or dot multiplication, vector or cross multiplication of 2 vectors A and B. This is the dot multiplication or scalar multiplication of 2 vectors A and B. Then we have multiplication of a vector by a scalar. This is a scalar, this is the vector. All this will be discussed in detail one by one. This is dot or scalar multiplication. This is cross or vector multiplication, and this is the multiplication of a vector by a scalar. Multiplication of a vector by a scalar. I have given the examples of addition and subtraction of vector in physics. Let us give an example of dot and cross product, and of course this also can be exemplified. The multiplication of vector has 2 parts, scalar and vector multiplication, or dot and cross multiplication. In scalar multiplication, we have the example of work. In physics, we will define the work done by a force as the dot product of 2 vectors. This is the force, and this is the displacement. This will be dealt in the chapter of work, energy and power. And the concept of power can be written as the dot product of force and velocity. Power delivered by a force is given as the dot product of the force and the velocity of the particle. All these 2 concepts will be dealt in work, energy, power chapter. Now, cross multiplication. We can give an example of this. One of the best example is torque. Torque, this is a vector quantity. In physics, there are some vectors like torque and angular momentum, which can be expressed as the product of 2 vectors. Torque is defined as a product of the position vector and the force. The torque applied by the force is given as the position of the point of application of the force with respect to the origin and the given force. The angular momentum of the vector with respect to a particular origin can be given as the position of the particle with respect to the origin cross the linear momentum of the particle with respect to that origin. So these are some quick examples given you for multiplication of vectors. And I will leave you the third type of multiplication of a vector by a scalar, that will be dealt in detail in the forthcoming videos.